monitor. Reload. Okay, there you go. Now that we have drop my phone. Okay, now that I've completed day 2 in about 5 days, let's go. Set away.
And that's really critical. All right, we are ready to start here. Look at that timer. Stream begins now. Ladies and gentlemen, the timer actually worked. All right, so I wasn't that sick last night, I guess. Ladies and gentlemen, thank you for joining me. Welcome to day 3 of Handmade Hero. I am a little bit sick and I apologize, but I have some cough drops here, so I am going to try to get by. We'll see if I don't need them, I won't use them because I'm afraid they might make some weird sounds with the microphone, but we'll see what we can do. All right.
Let's go.
Let's get started. If you remember from last time, we were at the point where we had just gotten a Win32 window up, but we had not really finished our application. And so there's some things that we have to tidy up first, and then we need to start drawing to our window the way that we actually want to start developing our own renderer, meaning something that will allow us to make our own buffer of pixels that we can write, basically our renderer any way that we want to work on, and then we need to basically give that to Windows so that it will display it in our window for us. And this won't necessarily be the most efficient way to render things on Windows, because nowadays everything goes through the 3D graphics card. But before we ever do anything involving the 3D graphics card or any of that stuff, like I said, I want to show you how to write everything from scratch yourself. And so what we're going to do first is we're going to use a slightly slower method, which is we're going to do all the rendering ourselves, and then we're going to put it to the screen. Okay, so this is sort of, in some sense, going back to the old days when this was actually how you had to write a renderer, because there really wasn't much in the way the graphics card could do for you. You wrote everything yourself to a buffer, and then you just told the graphics card, hey, this is the buffer that you need to display. And so that's basically what we're doing, and that's the first step in learning how a renderer works. Here we go. I'm going to open up Emacs. And by the way, I should say this, I hadn't said it yet in the stream, but if you are someone who has gone to the website and has pre-ordered the game, then you will actually have a zip file that looks something like, where are they here? Something like this. Basically, you will have a zip file that's got this stuff in it here. And what you want to do is you want to look inside your zip file, and there'll be day numbers, day 01, day 002, and so on. So if you are watching this video again sometime in the future, you will want to grab day 2, which is the day before this, unzip that, and that is the version of the source that we are starting with. So to make sure everyone's in sync, please make sure you do that before trying to follow what's going on here, because otherwise your source code will be out of date. So we've got one source file so far. It's win32handmade.cpp, and this,
I just realized I only have like one. Well, those are the same, I guess. Well, I can add some more messages later.
right
if
here
needed.
is our window callback. Now you'll remember what we did last time was we made a little message loop here, and Windows basically has a message queue for our application that it stuffs things in, and we have to pull them out one at a time, translate them and dispatch them, and then we will get them in our window callback. Now, we also talked a little bit in the Q&A, I believe, about why we have to have a callback at all, because if we're the people who are pulling the messages off the queue down here, well, why can't we just call whatever function we want? And the reason, as we saw in the Q&A, is because Windows reserves the right to call us back at that window callback anytime it wants to. It does not have to do it inside this dispatch message. That's the sort of mental model that they were going for, is that they call us back inside dispatch message. But, of course, Windows, things get crazy, so they started having places where it calls us out of the middle of nowhere. So anytime we call into a Windows function, no matter what it is, we kind of have to be ready for it to potentially call us back in there. Okay, so what we did and where we left off is something that is not really sufficient for our purposes. Basically, we had two things that we had to fix. One is that you'll notice, and those of you who tried at home, I'm going to go ahead and launch the debugger here so we can take a look at our program. So for those of you who are following along at home, you know that when you run this application, you end up in a circumstance where there is really nothing you can do with it. You cannot close it. I mean, you can resize it and see our black-white alternating pattern that we decided to have in there just to make sure things were working. You know, you can do all that, but you cannot close the window. And so really there's no way to exit this application without going back to the debugger and hitting Shift F5 or going into debug here and hitting stop debugging. And that is because we are not yet handling the close message. Okay, so in order to handle the close message properly, there's a couple things that we have to do. The first thing is we want to go back here and take a look here at the loop that we created that's pulling these get messages off. Now if you remember, if we go back to MSDN, and we looked at this the other day, but if we go back to MSDN, the documentation for get message is very explicit about what's going to happen when we call it. It says, in fact, it even gives some sample code down here. It basically says that there's a possibility of a return value of 0 if the WM quit message is posted, which is basically a way of Windows telling us that it wants our app to exit right away. But there's also the possibility of a -1, which means there was some kind of error in the get message and we should exit as well. So, given those two things, we checked for greater than 0. What that basically means is that if we want to exit this application at the moment, what we will have to do is basically get this thing to go ahead and get a WM quit message. And there's a really easy way that we can do that. We can actually tell Windows to just go ahead and post a quit message right on our queue. There you go. Now, if you take a look at post quit message in MSDN, again, always get used to MSDN. And by the way, I'll mention one other thing that someone wrote in and told me about that's pretty important. When you go to MSDN, we have not had this happen on the live stream, but somebody had it happen at home, where sometimes it'll come up with the documentation for Windows Mobile or something. And the reason that you care about that is because the documentation that we want has stuff like this in it, which says which version of the desktop Windows you want to use in order to support it, right? So we need to know that information, and we also need to know, sorry, I said that poorly. It says what the minimum supported desktop version is, so we know what our game can ship on, minimally. So Windows 2000 Professional is the earliest thing we could ship on. No problem there. No one's using anything before XP these days. But you also have the library and the DLL name here, which we need to use to resolve unresolved symbols, and we saw that in the previous stream. So make sure you are actually looking at the desktop version of Windows, which should say here, if you're not seeing things like minimum supported client Windows 2000 Professional or some other desktop version, then you need to make sure that you can switch to that. And I think you use the desktop technologies here, develop desktop, I don't know. MSDN changes so frequently, it's hard to say. Hopefully sometime during the stream we'll have the mobile one come up and I can sort of fuss around with it and get us to the right place, but there you go. All right, so post quit message basically posts an exit code as part of the quit message, and the exit code is just something that if we were posting this quit message in some kind of an error situation, it's basically just a way that we can sneak a little numeric value into that quit message. And if you look at the quit message, WM quit, it's basically a thing here that just is opaque to us. But when we do that post quit message, we'll be able to get this exit code back out if we really wanted it. Now we don't care about any of this stuff because we're a game, and games don't interact with Windows in hardly at all, basically. But if we did care, we would start to think about, oh, do we need to pass error codes back and all these sorts of things. We don't care about that at all. All we want to do is post a WM quit message in response to WM close so that we will fall out of this loop. Now there's two things we could have done here. And I will show you how to do the second one as well, because it's probably a little more proper, even though, again, as a game, we don't really care. So let me compile that. Let's go ahead in here, and we'll go ahead and set a breakpoint on that line. Here's our Handmade Hero app. When I close it, you will notice we get this post quit message. And when I hit F10 to step over that, I'm going to set another breakpoint down here just so we can see. When I go ahead and step over that, it has now posted that WM quit in our queue. And what we will find is that eventually now we will actually get that WM quit message, so this message result will come back as false eventually. Now remember, there's other messages in this queue, so it won't come back right away, but after a while, when we hit F5, we will get into a situation that message result is in fact false or 0, and we hit our break. Break breaks us out of the infinite for loop, which is this guy right here, and it ends the program. Now you may be asking me, or ready to ask me, Or if you are one of those people out there who is very, very C++ focused or object-oriented focused, you may be having a fit right now, and that is okay. I apologize for that. I hope that it does not cause you too much mental anguish, but you will be upset because you will note that I did not close my window. Now, one of the things that people like to do a lot in object-oriented programming languages is they like to make sure that they always have completely symmetric construction and destruction, or acquisition and release of their resources. And what that means is that every time you make something, such as create window EX, where we made a window, or register window class, where we registered a window class, you want to make sure that if there is some way to clean that up, that you do so. They do that even if there is no need to clean it up. Now, I would love to rag on people who do that. I'd love to say some disparaging things right now, but here's the honest truth. I was one of those people. I was one of those people for a good probably 3 years of my life, and I wrote code like that all the time. It's the only way I programmed. Everything was written exactly that way. Some people call it resource acquisition is initialization. Other people might just think of it as having everything wrapped in a class with a constructor and a destructor. There's a lot of different methodologies that sort of have this same thing at their core, but they all boil down to that same thing. And so they would never want me to do something like creating a window that I had no plans for destroying. But later on, as I programmed more and started to ship a lot more real-world applications and cared about performance a lot and cared about a lot of things that I didn't care about or know about during the times when I programmed like that, basically what I found is that that is a really bad way to program. And the reason is because it is almost always the case that things are better acquired and released in aggregate. And what that means is that instead of thinking about things individually, you always think of them as part of a group that gets handled together. And that is the way to think about things. And what that means is you can't be myopic and look just, you know what? The tea wasn't doing it. You were asking me about cheating on my almond milk with the tea. The tea wasn't doing it. We're switching to the almond milk. There it is. All right. Sorry for the interruption. It has to happen now and again. Anyway, what you need to do is stop looking at things in that myopic way that focuses on the individual creation and destruction of one resource and start thinking about creation and destruction and acquisition and releasing in waves. Now, you don't have to worry about that too much because we're going to be getting into those sorts of things a lot more later when we have a lot more resources to deal with. But right now, the reason that I wanted to bring it up is because what we're doing right here is we're creating this window. Now, we know that as long as our game is running, we are going to leave this window created. And if we ever do destroy it for any reason, we're going to recreate it right back again right immediately. And the reason is because we can't display our game without a window. So we know as long as the game's running, there's a window. When we exit this application, Windows will bulk clean up all of our windows, all of our handles, all of our memory. Everything gets cleaned up by Windows. So if we actually put in code that closes our window before we exit, we are wasting the user's time. I know it sounds strange to say it that way, but that is the truth. If you've ever the user will
I missed that.
too much because we're going to be getting into those sorts of things a lot more later when we have a lot more resources to deal with. But right now, the reason that I wanted to bring it up is because what we're doing right here is we're creating this window. Now, we know that as long as our game is running, we are going to leave this window created. And if we ever do destroy it for any reason, we're going to recreate it right back again right immediately. And the reason is because we can't display our game without a window. So we know as long as the game's running, there's a window. When we exit this application, Windows will bulk clean up all of our windows, all of our handles, all of our memory. Everything gets cleaned up by Windows. So if we actually put in code that closes our window before we exit, we are wasting the user's time. I know it sounds strange to say it that way, but that is the truth. If you've ever had one of those applications where you try to close it and it takes a while to close down and you're like, what is going on? All I asked you to do is close. Well, honestly, a big cause of that is this sort of thing. It's thinking it has to go through and free all its resources manually and tidy everything up, when in reality, a lot of those things, if they had been thought about as in terms of waves, it would have closed like that. Just something to think about. Again, I apologize to object-oriented programmers out there who are having a fit right now. What can I say? I'm sorry, that's just not the way I code. All right.
Interesting. I never really thought about that. To be fair, I used to do the same. I used to do the same thing. I always think of like cleaning it up immediately. Interesting.
So, we are letting our window die. The reason I said there's a little bit of an oddity here is because we handled the WM close message and not the WM destroy message. We left the WM destroy message floating, sort of blowing in the breeze, if you will. And so if you want to be a little more appropriate or a little more clean here, you could do something like this, where you pass both of them. Or if you want to satisfy even the sort of try to tidy everything up sort of way of doing things, you could even call destroy window, which closes your window and kills it, right here. Or you can do something even more pernicious, and it is probably honestly what I am going to recommend that we do, which is that we are going to instead talk about actually having a variable that controls the loop down at the bottom so that it will exit on its own. So basically what we're going to do here is inside our statement that used to be an infinite loop, we are basically just going to say while we are running. And this will give us a global Boolean flag that we can go ahead and kill anytime we want to. And we're going to talk about this in one quick second. But basically what we're going to do here, actually I'm going to initialize this in the way that I normally do. What we're going to do is we're basically going to have a giant a Boolean global that says whether we're still running, and when we go to close the app, or if our window gets destroyed for some reason, we are going to set it to false so that we exit. Now in the future, we probably will not actually do these things directly. What we will probably do instead, and the reason that I'm setting up this Boolean here, is we will probably only really do this setting running to false somewhere else. We'll have to do it somewhere else. So for now, it's going to be a global, but in the future we may move it. So this is a global for now. And the reason I say that is because the user may try to close our application, and we may not want to actually close the application. We may want to pop up something inside the game that says, are you sure you want to exit, or something like that, in case they may lose progress in their game. If it's like some kind of a roguelike situation where we're not going to save it, we may need to do something there, so we probably want to exit here. And with WM destroy, that is what happens when our window gets destroyed. And honestly, we may want to treat that case as an error. Let's say our window gets destroyed somehow that we did not foresee. We may want to flag that and go try to recreate our window later. So I'm going to do both of these as well. And really, this whole structure is going to be largely placeholder code for when we come back a little later and handle this with a message, and or I should say to the user, and handle this as an error, recreate window. We will want to come in here when we do the second pass on the Windows platform later, which will be much later, when we're going through and tightening everything up and making it super good for shipping. We may want to do those things. All right, so let's talk about this global.
Hang on, before I forget, I want to add some notes, because I did jump ahead. Destroyed or prematurely closed. But it can be restarted if it was unintended.
I am not averse to global variables, but I am also not a huge fan of them either. The dogma that says you should never have a global variable, I certainly don't buy into, but there is a reason that dogma came about, and a lot of the points are pretty valid. Basically, something we'll be trying to do to avoid making mistakes is we will be trying to avoid having code that should not be touch those things, for lack of a better term. And so the more we can make our code very clear about what it can and can't access, the better. And that is where global variables really pose a problem, because since anyone can touch it at any time, it makes it rather difficult for us to see. So this is something that in our Windows code right now is totally harmless. It is just a thing that controls exiting from the loop. Our Windows code is always going to be a little bit janky because it is interfacing with Windows, and Windows is not designed particularly well. It's not a very good API. So I am not concerned about doing things like using global.
I have to say it's better than the Linux API. At least it makes some sort of sense. It's a lot of work, but yeah, but the X11 one, The names are like all weird. Like, you open a display, so far so good. Then you have a screen, and then you have a window, and after that it gets all weird. Like, this is how you handle closing a window. And then this is how you set the title. Your name. I mean that, yeah. And you won't get events without this. And it's like not explicitly mentioned anywhere. Then you gotta map a window. And then you gotta sync it. Then you can see your window. It's like a lot of cheese. Yeah. And the events, some of them are like straightforward. Others, not really so. It's not too bad.
Globals in the Win32 platform layer. Most of our code will not be in that layer, and most of our code will not be touching anything that are global in there, to say the least. They will not even really know that it is there. So it is not really that big of a deal, but even so, I will probably move this out of globals at some point just so I can have a much clearer idea of exactly who can change running and when. So, that said, watch for me talking a little bit more about globals in the future, because we will have some more things to say, possibly even on this very episode, but for now we're going to go ahead and use them, because a lot of times you will use things as you lever code up into a working state, and then you sort of solidify it down, and you may start to pull things out that were global, or pull things that were in functions out of them, or those sorts of things, and that's what we're going to do. So we're going to have to go in here. We'll start running basically right before we go into our while loop, so we're going to set running equal to true. Now, one thing that you'll want to note is that static, we saw it once before. We used it in here, and this was to say that it persisted. Now, it's very confusing in C because static actually means different things depending on where you put it. It is not a particularly good keyword. And so one of the things that I actually like to do, and I'll start doing this right now, is to really define static into two different keywords, and I use the one that I actually mean. So if I have a local variable that is local persist, I will use that, and if I have a global variable, I will usually do something like this. There you go. So let's call them that, and let's actually put those in place. So instead of typing static, I just renamed that so we could see this is a locally persistent thing. It means that it stays around, but it is still locally scoped in here, right? Whereas this thing right here, this is a global variable, right? There you go. And now you can actually see what those are instead of looking at static, because static means two different things. In this case, what static meant was it meant that this value would stay the same after it exited this scope. So normally what would have happened is every time through the scope it would have set it to whiteness again, because it would have been a local variable. If it looked like this, that's what it would do. But as soon as I declare it static, it means it actually allocates space to store it for now and ever. So it assigns whiteness to it the first time, but then immediately after that, it starts assigning other things to it, and those things will persist. The next time it comes through this code, it will not do this initializer. It will not do it. And so it will retain the value that it had. So when we wanted to do this kind of toggle, where we toggle things back and forth, that was a really kind of convenient way to do that. Now we're going to rip that out because I hate using local persist. In fact, one of the reasons that I do this exactly this way is so I can search for things, like all the times when I use static to do local persist, because I don't mind if they're global variables, but I do mind if there are these, and I like to be able to get rid of them. Now, if that weren't enough for you in terms of confusion, the other thing that static does, it has one more meaning. What it does is it basically can define a function as being local to the file that it's in. So it can be basically used to say, don't allow this function to be called from any other file other than the one that it is in. And by file, I actually mean translation unit, and that's actually going to be important in the future, but for now, you can just think of it as source file. But to be continued. And so usually what I will do is I will say something like internal or internal function, right? I usually just use internal. So, all right. That are some pound defines just to change the word static into something that we can actually remember and use a little bit better and search for, more importantly, when we need to clean up our code base. And so what I'm going to do now is I am going to say that, well, oh, I forgot the thing that I was going to tell you as well there, which is that The other thing that's interesting about static that it does automatically for you is that if you use static to declare a global variable, it is automatically initialized to 0. So if I were to type this or this, I would basically, because false always evaluates to 0, basically that is exactly the same as just not saying anything. I do not have to initialize it to 0. It is initialized to 0 by default if it is static. So there you go. Okay, so if we were to take a look at this now, we could go in here and, oops. Static macro redefinition. Oh, duh. That's good. This is the sort of thing that happens on a stream when you are too busy explaining things. You put your stuff in the wrong order. My apologies. Awesome. Yeah, there we go. So anyway, yeah, defines. Oh man, it is a sick day. So defines always go in this order. That is just completely, yeah. Hopefully everyone knew that already because I think we covered those. But just in case they didn't, pound define. Since I already made the mistake, I might as well have to explain it again. That is my penance. Pound define always takes the thing you are trying to turn, trying to define anew, and then takes the thing you want to be. So it translates this into this, and I had them reversed, which is absolutely no good. So there you go. All right. So if we take a look at this now, and we run this application, we can close our application by hitting the close button, and it closes just like we wanted to. And basically what will happen there is it will set running equal to false, and we will exit right out. And again, all we will do is basically let Windows clean up everything for us because it's going to do that whether we like it or not. And if it's going to do that, then we might as well let it. So we now have fixed the only problem that we actually had with our application, which is that you could not close it, and you can close it now. Very exciting. We still have two things to handle here, activate app and WM size, but we are going to get to those in a second. What we really need to focus on now is the fact that we can't really paint anything meaningful. Now basically what we have to do here, when we did our paint, you'll notice that what we had to do was use GDI to paint things. And GDI is Windows' graphics API. And like I said, we want to do everything from scratch, so we want to interface with GDI as little as possible. Basically what we want to...
Hey Sammy. Stumbled across your channel because you were building a compile in Zig. Currently working on an interpreter in C++. Handmade hero looks very interesting. Hey, nice one. How's the interpreter going? Yeah, I sort of finished the compiler, so I've moved on to the next thing.
To do is take a bitmap that we have already rendered using our own code and all of our own techniques and just display it to our window. In order to do that, we have to basically ask Windows to allocate a bitmap buffer for us that we can write into, something that's in a format that it is comfortable with us handing back to it. Then we will write into it and tell it to go ahead and display. Now, this involves a bunch of Windows stuff, and I wrote down all of the things that I wanted to remember to tell you, so I'm going to open my notebook here and hope that I don't. They're kind of a little scattershot in the notebook, but hopefully I'll remember them all as we go through it. So, here's what we're going to do. Let me give you the big picture. Basically what we are going to do is we are going to ask Windows at some point, and I'm going to go ahead and just kind of type these out here as functions. We are going to have a function that's basically called resize div section. And div section is the name. It's called DIB, Device Independent Bitmap. That is actually the name that Windows uses.
Hang on, I just got distracted.
Let me give you the, I'll remember them all as we go through it. So, here's what we're going to do. Let me give you the big picture. Basically what we are going to do is we are going to ask Windows at some point, and I'm going to go ahead and just kind of type these out here as functions. We are going to have a function that's basically called resize div section. And div section is the name. It's called DIB, Device Independent Bitmap. That is actually the name that Windows uses to talk about things that you can write into as bitmaps that it can then display using GDI. Okay. We are going to have a function that basically resizes a div section or initializes it if it's never been created before. And basically what we will do is every time we get a WM size message which says that our Windows size has changed, we will basically call that. So we will basically force it to create an entirely new div section that is the correct
I'm currently learning how to implement scoping, which is pretty cool. Yeah, I think he uses C. Yeah, you're working on. Oh, okay, yeah. Oh, that's pretty cool. Have you done? I'm guessing you built the Lexer and the parser already. Oh no, you built in the parser.
Size, so it is the size of the entire window. Now, we won't quite, probably, want to do exactly that.
I think he's very anti-oop as well.
Because since our game is going to be a 2D game, and we will be wanting to render potentially at fixed resolutions, what we'll eventually probably do is only pick a size that is a reasonable size for our rendering that matches how we have done our source art. That also corresponds to roughly how big the window is, but for now, we can just go ahead and actually create it to be the full window size, and then once our game's renderer is up and running, we can start to think about those other things and control them. So, what we will do here is we will call resize div section, and of course what we have to do in that call is we have to basically know what the actual size of the window is that we ended up with after WM size. And the way to do that is a thing called getClientRect. Now getClientRect is a very simple function. If you remember, we had some experience with rect before. It was right here, basically. It's a thing which basically says, here is a left, a top, a bottom, and a right. It is a lot like something you might see in HTML, like in CSS. It basically defines a rectangle on the screen. And oops, that's not where I wanted that at all. And basically what we're going to do is we're just going to go ahead and grab the rectangle for our window. And the reason that it's called getClientRect instead of something else like getWindowRect, which also exists, is this just gives us the part of our window that we actually can draw into. Because if you look at a window, so for example, let's say I go take Notepad over here, you can see that the actual part you can draw into is like in here, and then there's this like border frame thing, and that's actually all being handled by Windows, right? So there's not a whole lot we don't want to touch any of that, so we just want to know the size of the part that we can actually draw to, right? And now if we were full screen, when we go, because we're going to want to go full screen eventually, when we're full screen, that doesn't matter because there is no border around the window or anything like that. But until then, when we're using one that has a little border that you can resize, we have to take account for that. Or I should say, take that into account. Grammar. All right, so we are going to ask for the rectangle. You can see it takes an LP rect, and like I said, long pointer to a rect. That's that Hungarian notation coming back there. So we have our window rect, or I should say maybe our client rect, since the window rect is technically something else in Windows. It's the whole window, not just the area you can draw to. I am going to go ahead and get that out, and that will give us, just like we did down here, that will give us our width and our height. So basically we can just subtract the right from the left and the top from the bottom, sorry, the left from the right and the top from the bottom, saying that correctly. We are going to go ahead and do that to produce the width and the height of the buffer that we need to fill the whole window. That's basically how big we will need it to be. So we're going to go ahead and call resize div section, and excuse me, we are going to pass it that width and that height. So in here, we are going to get a width and a height, and we will basically need to build that buffer using Windows to give us a buffer that we can draw into. Then what we will do, once we have our div section sized properly, we will actually in Paint, instead of
Alexa is done passing in progress as well as the interpreter, execution of AST. Oh, nice one. Probably won't be building the game. I want to build the tools around it more. But yeah, we'll see how it goes. Cheers, Sammy.
calling this patblit thing here, which is not really anything that we want to do, we will do the begin paint, and we will use the rectangle that it passes us to basically update that rectangle with whatever the contents of our buffer was. So we're basically going to create a buffer in WM size, because we always get that anytime the size of the window changes. We're going to create that buffer. We're going to draw to that buffer during our game loop. We're just going to keep drawing whatever the state of the game is into that buffer. And then anytime Windows needs us to repaint, we're going to blit from that buffer into the window. We're basically going to copy what's in our buffer, or rather we're going to ask Windows to do the copy, since this is the only thing that can actually write to the screen like that. We're going to ask it to copy from our buffer into the space occupied by our window. Now we will also be forcing redraws at, say, 30 frames a second in order to do animation. We will be force blitting, so we will not only be painting inside WM Paint, which is just a message we get when Windows thinks some part of our window is dirty, like it went off the screen and came back, or some other window was obscuring it and went away. So we won't only be painting in Paint, but it's one of the places we'll paint. Okay. How do we do that? Well, you know what? I'm going to make a stub function first. So inside here, in between our begin paint and our end paint, I am going to go ahead and say, like, update window, like this. And actually, that I believe is actually a reserved Windows thing, so I probably can't call it update window. But that's actually okay, because you know what I like to do normally is I actually like to prefix my stuff with Win32 so that the platform layer, so it's clear what is Win32 stuff and what isn't. So that's okay. We'll just call it that, and then our names won't collide with Windows names. Windows has a lot of names to collide with. Okay, so when we basically get our X, Y, width, and height here out of the rectangle that Windows asked us to repaint, we will go ahead and pass them, like this, to our update function. And of course, since now we actually will need the window handle, because we're going to actually blit to the window, we're going to pass it that window handle as well so that it can update it. And then we are going to go ahead and erase this stuff here. So that got rid of our locally persist thing, which, like I said, I don't like and I wanted to get rid of. So we're going to now move this up here into an actual function. The function takes an hwind, right, the window handle. It takes the X and the Y that are going to be the upper corner of that thing. I prefer X, Y, width, and height instead of the top, left, bottom thing. That's just me. So I don't use the naming convention that Windows uses where it's right, left, top, bottom, etc. I use X, Y, width, and height. I just think it's a little clearer for me. It's easier for me to remember. And in here, we are going to update it. So what we actually want to do here is we are just going to call a function that is called, I believe, where is it? Let's see. So dib section. Can we get a dib section? There we go. Guess we should start by creating one. So we are going to have to call create dib section to get it. So we might as well start with that as well. We're going to need create dib section to ask Windows to make us one of these bitmaps. And we are also going to need the function to blit it, what is the best way? There's a couple ways. There's stretch DI bits to device, but that actually changes the scale. Which one did I use? I'm trying to remember which one I normally use. I guess stretch blit would be the right thing to use. So this is a quandary. So this is the one I was thinking of using. Stretch DI bits to device. Let's see. Or is it? I guess it's not even to device. I think it's just stretch DI bits. Yeah, there it is. Stretch DI bits. So this is the one that I was thinking of. And I'll tell you what that one is, and then we can maybe think about whether that's actually what we want. So what this one basically does is this one takes our dib section, the thing that I was saying we're gonna have to create, our device independent bitmap section, and it blits it, but it allows us to scale it at the time. And I was thinking that would be a good idea, because then we could always render to the same size, and then we would just, scale it up to the size of the window. And I don't know, so that may be, you know what, I think that's probably what we're going to want to use in the end, so I'm going to just go ahead and use that one now and allow Windows to do scaling in there if we want it to in the future. I'm going to use another kill rectangle if people like that in the previous stream. Kill rectangle is a fun thing to get rid of those specifiers. Okay, so I'm gonna actually start with that, because I think that's what we're gonna want to use in the end, because basically, like I said, if we decide to use a fixed size buffer or a couple different fixed size buffers to do our rendering, and then we want Windows to kind of blow it up to the size of the window or shrink it down to the size of the window, depending on the circumstance, we're gonna need stretch DI bits. So I think I'm just gonna go with that. And if it turns out to be a bad call later, we will change it. All right, so all this function does, it's very, very straightforward. It is a rectangle to rectangle copy, and I'm going to explain coordinate systems a little bit later on. But basically for right now, if you can think about two rectangles, we're just going to copy one rectangle to the other. And in this particular case, the rectangles can be different sizes. So we're going to take a rectangle of one size in one buffer and copy it to a rectangle of another size in another buffer, doing scaling along the way if we need to. Oh, you know what? And here's one thing that I forgot. We don't really want the window here, do we? We want that device context, because we already had the device context right here. So rather than having to get the device context from the window, which we could do, let's just go ahead and pass that in there, because that's the thing that we actually have to pass to Windows. So there we go. There's our device context. So we will go ahead and put our device context.
If I'm not wrong, in X11 is something called graphics context. If it's the same thing.
In there, first parameter. Now we need the destination rectangle. So the destination X, the destination Y, the destination width, and the destination height. And basically that is some subsection of our window. So we are going to pass it basically the exact things that we got from RC Paint. So basically this is the rectangle that Windows wants us to fill, right? That is the part of the window that needs to get redrawn. So we're going to blit to that, basically, right? Then we basically have our source here, our source, our X, Y width and height that we are blitting from. And since we are going to start by just making everything exactly the same size, our back buffer will be the same size as our window, this is exactly the same. We are basically having two buffers. One is our window that we're drawing to, and one is the buffer that we are actually drawing our stuff into with our renderer, and we are just going to copy one from the other exactly the same. So then we have to pass basically a pointer to the bits and a pointer to the bitmap info. We have to do some extra stuff here. You don't know what any of these things are yet because we haven't talked about them, and we're going to talk about them in a minute when we actually create the resize div section. But for now, I just want to look at these two additional parameters that control how stretch DI bits work. So let's take a look at MSDN again. Go down here. You can see that basically the usage tells you what kind of a picture this is that you have done, what kind of a buffer you have made. There are two kinds of buffers. One is palletized and one is RGB. Now, you all know what RGB colors are probably because you have all seen them before in a paint package or something similar. I'm going to bring up Color Cop, which by the way is a great free utility that everyone should have in their machine. I absolutely love it. But I'm just bringing it up because these little RGB things, or this little guy that you see in Windows all the time, or any kind of color picker like this, just shows an RGB color, which is basically three values from 0 to 255 that say how much red, how much green, and how much blue are in a particular color. We'll talk a lot more about colors much later in the series, but for now, you are all very familiar with that. Well, that is what this is. So if you want to make a back buffer that is basically colors specified in that fashion, where every individual pixel has an RGB value, then you want to pass this, and that is what we're going to do. So we are going to put that in there. There we go. Okay. But I will quickly say what this is. What is a palette? A palette is if you would like to be more indirect. So let's say instead you would like to only use, say, 16 colors total. 0, 1, 2, 3, 4, 5, 6, and so on. And so what you want to write into your buffer, for example, are just numbers that correspond to some color, kind of like Pantone matching, or basically some paint chips where you've enabled them 0 through something, in this case 16 bits, so 0 through 65,000. Basically, you then have a palette which is specified in RGB per color, so per index color. So basically it's indirected one time. So you're basically saying the things that I actually put in this buffer just refer out essentially to another buffer that will tell you what the color is. And this was done back in the day to make things smaller. It's basically a way of compressing the size of the buffer, because since an RGB value is at least three 8-bit values, one for R, one for G, one for B, that's 24 bits, you could get away with less by using an 8-bit or a 16-bit palletized mode, where you basically just use, say, 8 bits to say what color you're going to do, and then those 8 bits told you to look up in a table of colors that were specified as RGBs. You don't have to worry about that at all because those days are kind of long gone, although they sometimes come back when you're doing things like texture compression. But fortunately for us, we don't have to deal with that. We can actually do direct RGB writing into our buffer, which is much, much more convenient. So, finally, we have a raster okay. Too sick to talk today. Raster operation code. And the raster operation code is something that says what kind of bitwise operations you want to do. Now, if you remember from the intro stream, there are a lot of bitwise operations, things like XOR, things like AND, those sorts of stuff. And if we go look where it says they're documented in BitBlit, you can see those here. And basically all this does is it says what to actually do to the destination. Now, all we wanted it to do, we didn't want it to do any fancy bit operations. We just want to basically overwrite the destination with the source. We just want to copy. And so what we're going to do is actually just use source copy, which is defined exactly as that. It is a numerical code that tells StretchBlit to go ahead and copy the thing directly. There you go. So that's really all we're going to do with StretchBlit. That will update our window for us. This will get a little more complicated as we start to handle other things. But all we really need to do now, if we want to update our window, is we've got to find a place to get these bits and the bitmap info from. And the way we're going to do that is through create div section. This is the part where we actually create the back buffer, because obviously to put that back buffer to the window, we have to actually make it in the first place. And you can see the things that are involved here. First, there is a bitmap info structure, and we'll talk about what that is. There is a h-bitmap, which is a handle to a bitmap that it returns to us. So this is actually our bitmap handle that is coming back to us from create div section. Thank you, create div section, for that. We're going to need a device context, but you know what? That device context is not going to come from where you think it's going to come from. It's going to be a little bit bizarre, but we'll get to that. And then we're going to have to look at a couple of these other things here. We have some other things that we've got to specify. So let's go to the MSDN and check out what our options are. Create div section. Okay. Here we go in create div section. We have to get a device context, and I'll talk a little bit about where we're going to get that in a second. We have to pass a pointer to a bitmap info, and that bitmap info is going to be something that we fill out. So this is an easy thing to do. We'll just go ahead and pass that, and we'll fill this out in a second. There we go. The iUsage parameter. So what is iUsage? Again, this is the exact same thing that it's asking us. When we create it, it wants to know, is it going to be palletized or is it going to be RGB? And since we're
Hey, Crick. Crick, Yashir. How you doing?
splitting in RGB, we used RGB in StretchBlit. We need to use RGB here as well, because that is what we wanted, right? Then we have a pointer to the bits. And so this is actually the big moment. This is the actual memory. This is the bitmap memory that we are going to receive back from Windows that we can finally draw into with our own renderer. That is the big thing that we wanted. That's what we really wanted out of this whole platform layer, and that's what we're about to get finally, after 2 days. So, the H section...
It took me 5.
Excuse me. Is basically something that's used if you want to do something fancy with your div section. That's sort of doing it out of core and writing it into, I guess, into a file or something like this. We don't care about any about this stuff. We just want to allocate one in memory for us. We don't want it to back it with a file or do any of this stuff. I don't actually know if it does back it with a file. It may just actually use some kind of memory mapping for it. I don't know. I've never actually used this parameter, so I don't care at all about that. And we're not even going to spend any time on it because time is of the essence here on this stream. And finally, we have an offset, which is referencing this thing. So since we know that we're not passing this thing, and it's ignored if this is null, we can ignore that as well. So there is our create div section call. It will create the div section for us, and pretty much that does everything we want to do, except we did not fill out the bitmap info that we are passing to it. So what on earth is a bitmap info? Again, this is all the vagaries of programming on Windows. It's a bit esoteric, and I don't blame you for going, what on earth is going on here? It's just the way it goes.
That's exactly what I'm thinking.
Here we are in the bitmap info. So, we have a bitmap info header. It's called .bmi header, and we have an RGB quad, which is BMI colors. Now, this is a little syntax that's used in old school C, and then basically, if you define an array at the end of something, it allows you to make it variable length. You can basically keep...
I mean, you don't have to call me sir. Okay, I'm guessing you're going to college. Can you tell me how should I start my tech journey from zero? I don't have any clue about coding at all. I'd say try to join. I mean, what really worked for me when I was trying to learn was to try and join a community. I don't know if you've heard of this boot.dev and there's code 3. Yeah, it works because you get feedback on what you write. I think it's a lot more easier way of learning. Yeah, I'd say try one of those. You can start there, and then from there, and then just, yeah, I don't know, just follow your curiosity, I'd say. Like, well, I don't have the YouTube chat. I can add it. Dev and Code 3. Both, like, Code 3 is really good too. This is how I really understood programming, because I got feedback from a lot of other software engineers. I think that one, it doesn't matter. You can just pick any. Where can I find my chat? Where is... I have no idea. How does YouTube work? Just a second. If you have no idea about coding, I'd say pick like a high level language like Python or JavaScript. Okay, there we go. And then just a second. I can hear myself. I'll leave this here. And I think both of them are quite free. You don't have to pay anything initially. Are you on Instagram? No, not really. Don't use Instagram that much. Yeah. Where was I? Here. Yeah, as for the language, I'd say pick JavaScript or Python or C. Actually, C is pretty good too. You could try doing this Handmade Hero. It does give intro into C, and you actually build something useful. Oh, I should send this to... Where is it? Here. Yeah, this one's pretty good too, even if you're starting. I started with C, but I really learned when I wrote JavaScript, because I could see output. Well, and also because I didn't know about Handmade Hero. If I would go back, I'd probably start with this one. Yeah, and I think the most important part is you've got to try and write the code yourself without looking up how it's done. You look parts of it, but find out how to read the documentation, and also find out how you can find answers when you need to. I think that's the important bit. Okay, I think that's everything.
Keep on going off the end of this thing, accessor wise. I'm not even going to begin to talk about that and how that works or anything like that, because we don't care about that right now, and I don't think you should really, I don't really recommend ever doing it either, but if you really care about it sometime in a Q&A, I will tell you what's going on there, because it's super janky and weird, but it works if you think about it. Anyway, we don't care about this because we are not using a palletized buffer. Like I said before, we are using RGB values, and we'll see how those work in just a little bit. Probably tomorrow's stream will be a lot about that.
You're welcome, and good luck. Have fun. I mean, it's a lot of fun to program. You'll be fine. Just start. I think the rest sort of figures itself out.
But anyway, this is basically where the palette goes. It's a variably sized array that will contain all of the colors that you plan to reference in your buffer. And since we don't plan to reference,
And since you're also like going to college, you're like no pressure to find a job immediately. I'd say try and build things that you actually enjoy, even if it's like no useful. It doesn't matter initially. Just, yeah, I'd say follow your own curiosity.
any colors,
And then based on what you want to build, you'll find out like what sort of programming language you need to use, etc. Okay, that's it.
we plan to write the colors directly into the pixels where they belong. We don't have to worry about that at all. So BMI header is really the only thing that we need to know about, and because we are going to have to fill that out in order to specify what we want. So in here, you will see all of the things we have to specify.
Hey Marcos Lopez. But code is not dead with AI. I mean, I don't know. I can't tell the future. At least for me, I don't really care much about it. I like programming, so I just keep doing what I would have done if AI was not here. I'd say if anything, if you are learning to program, you can actually learn faster now, because you can just ask questions to the AI and understand parts of it. As for if it's dead, currently, right now, I'd say it's far from dead, because I mean, I'm working as a programmer and people are still writing code. So as for the future, I don't know. I mean, it could be, maybe not. But you can't like make decisions based on something that might happen in the future. Let's say 5 years later, we're still programming. You not even, I don't know. Yeah, I don't know. It doesn't make sense for me to think too much about it. Because I don't know. Maybe somebody else does. But for me personally, I just enjoy programming too much to like to quit and want to do something else. So I will program as long as I have a computer. And yeah, we'll see the rest as they come in the future.
So, BI size. It says the number of bytes required by the structure. So that's basically Windows asking us to put into the structure itself how big the structure actually is. Now that makes some sense probably because maybe they want us to include like this if we had one of them or whatever. Sometimes Windows just wants you to pass the size of things so they can tell what version of the API it was that called them. But basically what we need to do here is use that size of function that we saw before, where we can get the size of things, we saw that in the intro stream, to basically just find out the size of the structure itself. So hey, whatever the bitmap info structure is. Now, do they want the size, which do they want the size of, ladies and gentlemen? Do they want the size of this, or do they want the size of this? That's the real question. Number of bytes required by the structure. It doesn't say. An application should use information stored in the BI size measure to locate the color table in a bitmap as structure. Oh, here is the clue we needed. It says the color table, which is I believe this right here. It says the color table is the thing that comes the BI size, yes, BI size after. So this is exactly what we want. Okay, so if you were in the intro stream, you remember us doing something exactly like this. We basically took a pointer we cast it to a char star, which is exactly what they're doing here. That is Windows #define for a char star. We casted a pointer to a char star, and we added a memory offset to it to get to a new place in memory. People who remember the stuff from the intro stream, you are very happy right now because that is exactly what you need to know. So now we know what that size parameter actually is. The size parameter is how big the header is so it can skip to the color table, which to me suggests that it should only be this size. It should only be this thing here, and it should not include the color table. So we're going to go ahead and use just the size of the header portion like that. Next field we need is the width. We know what the width is because that is getting called right here. We know what the height is, so that is right there. We know what the planes are, because that is sort of an old school notion. Basically, bit planes used to be when you would specify multiple chunks of memory that get combined to give you the color. We don't have to do that anymore. Thankfully, all of the pixel RGB values are not stored in like a red plane, a green plane, a blue plane, or something where you have 1 bit per each part of the red value or anything like that. We don't have to worry about that, thankfully. Everything is actually per pixel packed together nowadays, and you can't even specify anything other than 1, apparently. It says this value must be set to 1. So we don't have to worry about that. We don't have planes. We only just have our back buffer, so that's good. We'll talk a little bit more about these things when we decompress, maybe on the Friday stream when we go back over everything. I will talk a little bit about the history of some of those things for everyone. But for now, I want to keep going. The bit count is the number of bits per pixel. Now, 24 is actually how many we need. But I'm going to ask for 32 for reasons that will become clear in a little later. The reason I say 24 is because we need 8 bits for red, 8 bits for green, 8 bits for blue, just like you would see in, say, HTML or something like that. We want an 8-bit color for each for now. And I'm going to actually ask for 32 because I want things to be D-word aligned. But you don't have to worry about that just yet because we're going to talk about alignment totally separately. All right. And, that will involve us opening up the Intel architecture manual, which is always fun, ladies and gentlemen. You will enjoy it, I promise you. So, we can then say what kind of compression we want, and we do not want this compressed at all, because what we want to do is be able to write to it as fast as possible and blip from it as fast as possible. We do not want it to be doing any fancy compression, so it's going to be thinking about things at all, trying to compress them. We do not want that. So we're just going to pass BI-RGB for the format. Sorry, what was the actual format name? It is BI compression. BI compression. There we go. Size image. What on earth is that? The size in bytes of the image. This may set to be, oh yes, to be 0. So basically that's just going to, that is just going to show up if you actually have a compression format where Windows wouldn't know how big the thing was going to be because you were going to do some compression on it. Pels per meter is sort of totally useless for us. Why would we need to know that at all? That is something is only if you were actually using some kind of print output. Pixels per meter, we don't even have anything about that. So can we set those to 0?
Pixels per meter. That's weird.
0, ladies and gentlemen. Is there a way to set those to 0? I feel like they could both be set to 0. So I'm going to set them to 0 for now, hoping that it does not mind, because that is basically for printing and that sort of stuff where you have an actual, or something where you actually care about the physical size. We don't even know what the size is of our display at this point, so we're in no position to say how many pixels per meter there are on it, because we don't know anything about that. Clear used, the number of color indexes. Okay, this is how many colors are used in the color table. I just said we don't have a color table, so we don't care about that at all either. And finally, BI color important, also not care about because we do not have any of that indexed palette stuff. Okay, this should actually go through and allocate our...
You only said about 2 or 3 values. You said the compression and the width. The rest is all like just
our bitmap memory for us, but we will not know until we actually try if we've done everything right. But I want to point out something that we now need to handle, and that is we actually need to free, well, we need to get our device context first, so we need to do that too, but we actually need to free this thing before we create a new one, because like I said before, if you go down here and you look at the WM size command, you will note that we basically have a resize deep section call will happen every time we WM size. So if we allocated new memory for our buffer every time, that would be bad. So what we actually want to do is just right before we create our new dib section, we could free the old dib section, or we can wait and see if we can get our new one first. And if we can't, we can keep using our old one. It's a tough decision. It is a tough decision, ladies and gentlemen, because basically there's a bunch of trade-offs either way, depending on how we do it. I am going to go ahead and say what we will actually do is we will actually free after. We'll create ours first and then free after. The reason that's a little touchy is because if we needed the memory from the first one in order to get the memory from the second one, because it was occupying too much memory, we would be kind of shooting ourselves in the foot. So maybe the other thing we could do is if it fails, yeah, this is hard. So you know what? We're going to put to do here, and we're going to say bulletproof this, and we're actually going to just do a free, straight up free first. So basically what we'll say is bulletproof this, maybe don't free first, free after, then free first if that fails. Maybe we'll give that a shot a little bit later just to be a little more resilient depending on these circumstances. Okay, so what we're going to do here is basically right here we will free it, free our div section, but then down here we will create a new one that we can then use to draw. So we're going to have to remember a couple things. As we can see down here, we need that bitmap info, which is this thing, right? So this guy is going to have to be persistent. So let's go ahead and put him out here, right? He's going to have to stick around forever. There you go. And now that will also clear him to 0. So that means all of these guys are cleared for us for free, right? Don't actually need to do any of that. Cleared for us for free out in the bitmap info. Then we've also got this bitmap memory right here, which is void star. And again, these global variables will probably not last long. We are going to make them unglobal in just a little bit. But for now, to keep things simple and to make sure that we are on time for the day, we are going to go ahead and use them because they are going to use sort of across multiple things that do not share a context that we can easily get to. But I'll show you a little trick for that a little bit later. And then finally, we are going to probably need that bitmap handle because without that bitmap handle, we would not be able to free it. So I'm going to store this as well. So there we go. And what I am going to do is I am going to say bitmap handle global variable. There we go. I am going to say at the top of this, if we want to free our div section, basically what we're going to have to do is if we actually have our bitmap info initialized. And since this is the first thing we initialize, I'm going to go ahead and switch on that. I'm going to say if that's actually initialized, then we assume that we will have to actually get rid of this stuff. I don't know if bitmap handle actually is something I can test for as well. Let's take a look at that. What does that actually find to be inside Windows? I don't know if that's a thing we can test on. Let's take a look. Bitmap, hbitmap. Type def, it is a handle. So I don't know if that'll come back as invalid handle value or what. That is a good question. Let's take a look at create div section and see what it says the return value is on failure, because I don't actually remember. There it is. It takes a little while in MSDN sometime. Okay, let's see. Return value succeeds. The return value of the handle.
Hey, Sansi30.
If the function fails, return value is null. Okay. So basically this will initialize to null, which is good, and we can also say if bitmap handle, that means we've got one, and so we will have to delete that bitmap handle. Now,
we all know 90% Linux users are nerds. Yeah, it is the video. I'm not Casey.
GDI is a little wonky. The way that works is basically when it creates a bitmap handle, which is going to actually track the memory
because in the video it's Windows
for us as well, it actually deletes everything through the same call, if I remember correctly. So basically you actually pass bitmap handles to delete object instead of something like delete bitmap, and it just figures out what type it was. So you can actually see here in the remarks, it actually tells us this, now that I'm looking at it. The system closes the handle to that memory when you later delete the dib by calling delete object function. So
the nerds part is not an insult. No, I didn't take it as an insult. Excuse me. It's instead very useful because I'm looking for help. You need the help of the nerds.
So yeah, I guess basically, you know, they just wanted to make only one delete call and you just pass everything to it, and it's an HGDI obj that it expects to get. So we may actually have to cast this if Windows wants us to pass it to it, because basically we actually have a HBitmap, and you know, I don't think it's going to do that autocast for us, but we'll find out. In fact, let's just find out right now. No, it was fine. Okay, that's totally fine. Oh, and I also forgot here, these are all in the BMI header, right? These are all in the header that we're setting here because this actual bitmap info thing didn't have any actual stuff in it. So there we go. Okay, so we're going to go ahead and delete this object here. And there's another.
I mean, there's a lot of. Okay. No, good.
I think we're going to actually have to do in this case. That'll happen in a second. But the other thing that we have to do now is figure out where we're going to get this device context, because we have a device context. We need to actually go ahead and create a device context that we can actually use to create our div section. So what it's going to do with that device context is it's going to create a bitmap that's suitable for use.
Most do you know about Android ADB? I don't even know what that is. I know Android, but I don't know. But that's about it.
With that device context. And so in order to do that,
you're welcome.
Basically we have to first get a device context that is something we can use to blit to the screen, because that is what we're trying to do. And the way that we do that is we use a thing called getCompatibleDC, and we pass it 0. Now I know that's a little bit odd and probably a little confusing to everyone. This is again the vagaries of Windows, but basically what happens here is, sorry, release DC. Basically what happens here is we can ask Windows to give us back a device context that's compatible with something.
Oh, you don't know what a bootloader is? I've heard of it. No, I don't know what it is. I guess, no, I don't know. Oh, it's the thing where you like try to jailbreak your Android. Is that it? I think I did it once when I was in college.
Right? And you can see if I actually pass it in here, and remember device contexts are the things that we use to draw in Windows. You can see that basically when we do create compatible DC, we pass it another HTC and say, hey, we need you to basically make something that we could use to draw in a way that's compatible.
Okay. Go on.
With this other
What's
thing that we're trying to use. And that's important to us because basically we have something we want to draw into that we're going to try and blit to the screen. And so what we want to do is create a device context that's compatible with the screen's device context, even though we are not drawing with the screen's device context. I know it's crazy. I didn't make this stuff up. Fortunately, once we're done with it, we're going to be done with it. Oh no, the 5-minute warning.
Why you, a Linux user, watching this video about Windows? Nostalgia? No, not at all. Because I want to build it in Linux. So I gotta know what it is that I gotta build. Yeah, I can show you what I have so far. I mean, I just started the window, so it still works. Yeah, this is all I have. No, not build Windows. Build the Handmade hero. Why would I want to build Windows? There's already...
Well, it's good to know that the app is working. We may need a little more than 5 minutes. We may have to go into the Q&A today. That'd be sad, but we might need a little bit more just to get us to the point where we're actually blitting to the screen. But we're almost there. If we get a device context compatible with blitting to the screen, we can then...
Oh no, I've gone insane for more than a second. Don't be surprised if I...
use it, and we will want to...
I can't tell you which one to follow. You gotta try. Start with. Just look up Handmade hero. Like I said, it would depend what you want to do, and then you can pick any one of them. So if you want to do like web stuff, then maybe pick the first one. If you want to do like backend stuff, maybe pick the second one. And if you want to build games, you pick the third one. Thank you, Sensei. I don't get any notifications. I appreciate it.
Actually, you know what? That's not entirely true. That's not entirely true. We want to just actually keep this around, is the thing. We want to actually keep this device context around, because why not, right? So we can actually create a compatible DC for this thing and leave it selected.
It is something about Windows? No, it's building the game in Windows. What do you mean? What do you mean, Sensei? What do you know?
I really wish that 5-minute warning wasn't up, because there's a bunch of stuff that we should probably explain here. I wonder if we have to break this into two. That would be sad.
Oh, yeah. I don't know, maybe someone wouldn't. It's possible. Maybe someone hates it. People are different. You never know.
Because we're so close. It's that moment of indecision. Do you go into the Q&A and do you finish it, or do you stop and wait?
Don't go into the Q&A.
Well,
You have to finish it.
I'll tell you what we'll do. We'll make a compromise. We'll make a slight compromise. What we will do is we will call create compatible DC here, and we'll actually create a DC.
Yeah, exactly. It's entirely possible.
That's compatible with something, basically compatible with the with
Just get banned for following. That'd be funny.
the screen. So we'll actually call create compatible DC with 0 to make a device context that we can use, that we can keep. So instead of having to release it, we will just keep it. And this will be part of the package that we will eventually wrap up into a nice little thing that we can use for doing this stuff. So this is our bitmap device context that we can use from then on. And if we know that we have done our stuff before, we will not need to make it, because I believe we can just use the same one forever, and that should be fine. But we could also shut it down and create it anew each time. I don't know. We'll see in a second. Point being, we will probably end the stream here because there is so much to talk about in here, so many new things that we did.
No. I don't know what the end result is. How can I build this? Maybe I have to go to day 4.
That I think we really want to basically have, we want to have enough time to actually go through everything and talk about, sort of decompress a little bit all the stuff that I did. So I'm not going to blow through the Q&A. We're going to stop and we're going to actually do real rendering tomorrow because we've basically done almost all of the work for it. So tomorrow we can just start fresh and start drawing things right away.
I didn't know the plan. I was considering if my PC would have had edible performance from old age. Yeah, I mean, I think Linux does run a lot faster. I joined Windows Beta Insider and I broke Windows and reset didn't work, so I switched to Linux. Yeah, I like Linux. I haven't used Windows for like years now.
Which seems like probably the better solution. So hopefully everyone's okay with that. We were almost there, but at the last minute, it was past. We grasped defeat from the jaws of victory, if you will. So, all right, I'm just going to clean up this. We changed the name of that to Win32 Resize Div Section. So now we have a thing where we actually do call in.
Tried Zorin. Oh, I don't even know what that is first, but it sucks ass somehow. Yeah, it's like maybe somebody's hobby project. I don't know what that is. I've only used Ubuntu or Pop OS. I don't know much about the other ones.
And we do resize our div section, but unfortunately we don't actually do anything with our div section, so that is not particularly exciting. Basically, what we have done now is we have made it so that when we go in to do our resize, we check to see whether or not we already have a bitmap handle. If we do have a bitmap handle, we need to delete that bitmap handle. So we go ahead and we do that. But if we do not have a bitmap handle, that means this is a time, well, you know, I can make this a little cleaner actually. Let's just see.
The distro that is advertised as an alternative to Windows and Mac OS. But Linux Mint is better somehow. I've never used Mint, but I believe you.
Say also, if we don't have a bitmap device context, we will also create one of those. And we never probably need to free that one, I don't think. We'll have to double check.
Oh yeah, I used to use Windows 2 for the longest time. XP, then I think Windows Vista, and yeah, I think that's it. I never used Windows 10. Oh no, I did use. Maybe, I don't know. Yeah, you get used to it. I mean, it's better than getting used to. I'd say it's much better experience, at least for me. Linux Mint is based on, yeah, okay. I like Ubuntu, just works.
Later, when we start to do testing, whether we would have to change, create a new one, if someone unplugged a monitor and plugged a new one in and set to a different display resolution or something like that, we may have to, I don't know. So it's a good question as whether we should create a new one or not here. So I'm going to go ahead and put a to-do down here. Should we recreate these under certain special circumstances? And we'll take a little bit, we'll take a closer look at that when we do the final stuff. We filled out our BMI header, we asked for our div section, and we should have gotten back our memory. So let's take a look and see if that actually worked. If it actually gave us the back buffer.
I've heard Linux can run without RAM, which is just... Can it run without RAM? It'd be terribly slow. I don't know about that one. Never heard that one before.
That we wanted. So we come in here, we hit the resize. Obviously, this is inside our WM size call. So we came in here, and we, by the way, you can always double click in here to move throughout the various parts of the stack. This is where we are in the stack right now. So basically this is, in fact, you know, and I'll just go ahead and step through it explicitly for you so you can see it. So basically what happens is we come in here, we get a WM size message, we get the size of the window by getting the client rect, and you can see the client rect in here. Right, there's the left, top, right, and bottom. We can turn out of hexadecimal display here and see that our window is 1424 by 729. A very interesting resolution indeed, but that is what Windows created us as. We didn't ask for anything in particular. You'll remember we said use default, so it did. There we go. There's our width and height. Oh, the Q&A begins now. We're in trouble. But like I said, we're going to call it for today anyway. So anyway, point being that we got our size correctly. You can see we actually did our math there, width and height. We go into the resize. We don't have a bitmap handle yet, so we don't need to delete object. We don't have a, oh, that's a bug right there. My bad. We wanted to do this if we don't have a bitmap device context, right? Because basically we want to create one if we don't.
Linux, I noticed a way better RAM management. Not only from distro itself, but also from some apps. A 16 GB RAM, really appreciate it. I think also because there's like just less stuff running on Linux. Probably why. I don't know if it's better memory management. But as I understand, it's mostly because it's just running less stuff. But I don't really know.
Have one. So we need to do basically this not equal to 0 if we do not have one. And the shorthand for that you can do also is just not that thing, right? So there we go. Okay. Glad we stepped through that. Caught an obvious bug right away. One nice part about stepping through your code is you get to catch some stupid mistakes that you will then have to go in and go, oh, yeah. So we go ahead and create one of those. Let's see if we got back something valid. We did. We are going to go ahead and fill out our structure. Let's take a look at that and make sure it looks like what we think it should look like before we go any further. There it is. Everything looks good. 32 bits per pixel, one plane. That is the size we wanted. This is the size of the bitmap info header, which looks good. And now we will see if we get a bitmap handle back. And we did. Let's see if we got our bitmap memory back. We got that too. So it looks like we have succeeded in getting our back buffer, but unfortunately, we are not actually going to be able to use it.
I just realized I've been running the wrong scene. Oopsie.
Sorry about that. Unfortunately, we are, oops, still got that
No wonder people were confused.
breakpoint in there. Let's get rid of that. Don't want to break every time we resize our window. So there is our window.
Oh, hopefully people did think I was Casey.
It is resizing at the moment, and presumably it is actually doing what it's supposed to do, although we have to do some actual work in here or testing to see if that's true. We can also take a look in the excuse me. We can also take a look here in the task manager by hitting Control Shift Escape, bring up the task manager. One thing that I
Hey Sensei. Yeah, I forgot. I was testing something this morning. Totally left it in the wrong.
like to do periodically, especially when I write something like that, that's going to be doing some kind of finicky things where it's like, oh, it sometimes wants to free this thing and sometimes it doesn't because it's doing something clever or thinks it's cool. I do a lot of things to double check to make sure that everything is kosher. And so one of the things that I want to look at is what our memory footprint looks like. So let's go ahead and see if we can find our application here. What did we call this? We called it Win32 Handmade. So there it is. We can see our working set right there, which is basically how much memory we are using at the time. And I am going to go ahead and go nuts with this to make sure that we are not leaking anything. And you can see that we do not appear to be. So that is good. If that number was going up like crazy or something like that, then that means we would be leaking something, but it looks like we are in good shape. Okay.
Interesting.
So I'm sorry we didn't quite get to draw into it. We did all the work to get it. It's kind of like, doing all the work and not getting paid, and that's a little disappointing. But the good news is tomorrow we will be able to start right away with drawing, and that is the fun stuff, ladies and gentlemen.
Yes, Sensei. Etaras.
That is the part where we actually start working on the game. So I'm going to go back and stick to our schedule, even though I really want to go do that. I'm going to stick to the schedule and say, let's open it up for Q&A. I will go ahead and start taking questions now.
Okay, but I'm kind of confused. Not sure. I took some notes because gotta like translate this to X11 now. But XM practice, get image from display output. I did hear something about graphics context. Drawing operations to avoid having to resend the same parameter with each request. Where's... oh, here. Clear and copy areas. No. Manipulate font, draw text. Display functions. Open, connect to display, obtain information. Oh no, we've already done this. Window functions, information functions, so I've done that. Fixed map and cursor. Doom can run on X. Yeah, I would assume so. It runs on everything. You mean like X11, the Windows system? Recently made it run on a Discord tiff, and honestly it's more about where I can't run. Yeah, I know. At this point it's like a running theme on the internet. Create and free seems okay. Some of these look familiar. X-maps can only be based on screen on which they are created. X-maps are off-screen resources that are used for various operations, for example defining cursors, styling patterns, or as the source for raster operations. Most graphics requests can operate either on a window or a pixmap. A bitmap is a single bit plain pixmap. Single bit plain pixmap. Okay. I guess I gotta create one. Challenge you to run. No. Alright, Santi. Thank you for hanging out. Have a good night. Get some sleep. Specifies connection to X server. Which screen? Okay. D. Why D? Okay, yeah, that's the screen. Not the window. The width and the height should be window. Depth of the pixmap. Okay, I'll leave this open. I think we found one of the many. And all I need is window information. Yes. Xget geometry, display, drawable, root window. X and Y, width and height. Okay, this is perfect. This is what I need. I'll leave this open. And I need this on events, event types, set a resize. Let's try map, unmap. Window crossing. That's property. Waiting for information about property changes to for a specified window. The window member is set to the window whose associated property has changed. The atom member is set to property atom and indicates which property was changed or desired. Oops, no. Window properties. I don't know if this is it. X11 Reese window resize event. Structure notify. I did see this somewhere. Did I? Resize request. Can report resize request events to clients wanting information about another client's attempts to change the size of the window. The X server generates these events whenever some specify window by colon configure, resize, or move resize. Okay, so we got out the event mask. And then you should get the event. What's the event mask for resize? Okay, I think it's called resize redirect. C dot resize redirect. That didn't seem. Keep press. Okay, it's called resize request. Then what's the event called? Resize request. What? No, something's wrong. Oh, hang on. Maybe it's called structure something. Button window. Visibility structure notify. There we go. Oh, it's this one. Okay, there we go. Mask and then dot resize redirect. Let's just print for now. Debug print window resized. I understand this correctly. Oh yeah, it doesn't. Does it? Besides request. So now if I... Oh yeah, there we go. Nice. Okay. So we need, when we resize, we need to get the new width and then draw there. Brilliant. What do you get? The structure of this event type contains okay, perfect. I can get the window display within height. To 10%. D height. Event dot Actually, based on the type, probably okay. Look for X resize request event. There we go. And then I can get the width and the height. Resize. Hang on. And dot X resize request event dot width. Okay, that's the type. What's the key? X resize request. My bad. Comma height. Okay. Okay, nice. Perfect. coffee. So we've got the resize. Now we need to draw stuff on the new window. We don't need this anymore. What was XGet geometry? Do we even need this now? Because we already have the width and the height, not the X and the Y. Just gonna assume we don't need it right now. And now I need to update the display. Oh, before that, there's something I wanted to check. Guessing this is the drawable size. Maybe, not sure. Most graphics requests can operate either on a window or a fixed map. A bitmap is a single plane fixed map. X11 bitmap. Abilities for the X window system. Rectangular images made of ones and zeros. Cursor shapes, icon shapes, and tile, and stipple pattern. Maybe I can find nothing. I gotta do something with the graphics context as well. I don't know. I'm gonna call it today. I'm gonna call it today there. I'll continue tomorrow. Because I'm not really sure about a few things. Because he did a lot of things. But what I understood is, whenever Windows resized, you get the new size and you print something on it using bitmaps. And also there was something about like create blitz section. It's the area of the screen where you're allowed to draw stuff. Yeah, few things to look into. Alright, I think that's all for today. Thank you for hanging out as always, and hope you have a good day. I shall see you tomorrow.